All right, well, why don't we get started here? So, look, you've almost made it, right? It's almost the end of the conference, and I know there have been interesting talks, but this is going to be especially interesting. And the reason that I know that is that I know what engineers like to work on, right? We do not like to work on cool new features, optimizing things. No. We like to work on fixing bugs in old code bases. Yes? Look how happy he is. This is great. So the fact is that when we're talking about confidential computing, like AMD SEV, it relies on firmware, trusted firmware. We know that when we have firmware, we have bugs. When we have trusted firmware, we have security bugs. And with confidential computing, things are always a little bit more complicated, which is a theme that we'll be coming back to a lot. So with confidential computing, when we have bugs, we have this problem where the person who is patching the bug is generally who owns a physical machine, so for instance, a cloud provider. The person who cares about the bug being patched is the tenant, right? So how is the tenant going to know that a particular bug is patched? Well, one concept that we have in the SNP architecture is this thing called the TCB version. And the details of this vary a little bit by generation, but this is an example of one of them. And this has what we call security version numbers, so these 8-bit values for each of the firmware components that make up our TCB. And it starts at the bottom there. We have this bootloader, which is the first code that runs when you actually turn on the CPU. We have an OS that runs in our security processor. We have the SNP firmware that implements all of our confidential compute functionality. And then we have our CPU microcode. Now, the general rule with these is higher numbers are better. And the values are different on each product. So when we release a new CPU, the values get reset. And that can even be true within a given generation. Now, the microcode here, this is already hot loadable. I'm not really going to be talking about that. But I am going to be talking about the SNP firmware because it is hot loadable architecturally, but that is not currently supported in KVM. And the current KVM code, or really including the rest of Linux, I should say, is we do support updating this firmware when the CCP driver is loaded. So you do not have to reboot your machine in order to pick up new firmware, but you have to unload the KVM driver in order to unload the CCP driver, which means you have to shut down all the guests, and so that kind of sucks. So the patches that have been proposed, and I'll talk about those a little bit later, allow for hot loading this firmware through a sysfs interface. This is supported as long as you are only running the newer guests, so what we call the SNP guests, not our legacy SEV or SVES guests. And these confidential guests can continue running while this update process is occurring, so it's minimally disruptive. So that's great. So the question then is, well, how can a tenant know how trustworthy the system is if the firmware can be changing underneath them right while they're executing? And so this is, of course, where attestation comes into play, and this is a very basic picture of that. And I think we've heard a lot about attestation already over these 2 days. But essentially, the guest is able to request an attestation report. The security processor builds a report with measurements from the guest, measurements about the platform, like the versions of firmware that it's running. And it signs that, sends it to a verifier who decides, based on some reference values or something, if it likes it or not. So when it comes to security bug fixes, how do you use this in order to tell if your system is actually patched? Well, if you've ever read the super interesting AMD security bulletins, you might find a table that looks something like this. And this is pulled from one a couple years ago. And there's one of these for each product in the bulletin. And this describes how each of these individual vulnerabilities are fixed and how you can tell that they're fixed. And in this particular one, there are about 10 CVEs that were all released together. That's something that AMD does, and I think other vendors do as well, just to kind of minimize how many software updates customers have to take. And you notice here that there are 2 mitigation options that are provided for these. So there is something called a platform initialization or PI package. That's a BIOS update. So if you want to reboot, you can take a BIOS update, and that'll have all these fixes. If you do not want to reboot, there is mitigation option 2, where there is hot loadable microcode or SEV firmware that you can load. So those columns are for the host, such as a cloud provider. The final column here is for the verifier. That's how you can tell if the host did in fact apply the mitigations for these CVEs. And so in particular, if you get an attestation report and it shows that in that TCB structure, your SNP version is, let's say, version 9, you're going to know that that one bug that's kind of in the middle there is patched. The one right below it is not patched. Right? So this is how you can then map this onto particular vulnerabilities that you may care about. The value at the top there, by the way, is just kind of the union of all those. So if you can pass that check, then you're mitigated against everything that's in there. And by the way, the ones that are marked NA, that's typically because those do not actually affect a confidential computing environment. All right, so how do you use the attestation report to check these things? Well, as it turns out, there's not one TCB version, there's actually 4. And that is partly because of the fact that these things can change through hot loading. So what are those? Well, the first one that is reported is the current TCB. So that's simply the versions of firmware that are running at the time that the guest asks for the attestation report. That's very simple to understand. It's probably not very interesting from a security standpoint because these versions can actually go backwards. This is a feature, believe it or not, we call try before you buy. So you can update the firmware on a node, decide that you do not like it, and then revert it back. Right? This is all in the context of high availability, that if there is some bug that we didn't find that you encounter, you can roll back that firmware, continue running, you don't have to reboot. Obviously, from a security standpoint, that's a problem if you can do that. And so we do have the concept of a committed TCB, which is the anti-rollback point. So after you have tested out that new firmware, if you like it, you can commit it, and then you promise that you can't go backwards there. There is a third version we have called a reported TCB. And this allows the host to lie and actually say that the platform is even older than the committed TCB. And the reason that we have this, I'll go into a bit more on the next slide, but this has to do with the certificate chain that you need to verify the report. And so we allow for, again, saying that you're older than you are, so therefore less secure, but not the other way around. And then the final one, which is probably one of the most interesting from a security standpoint, is the launch TCB. So the launch TCB is simply the committed TCB at the time that the guest started. So if you are looking at an attestation report and you want to tell if this guest was ever exposed to a particular CVE, you can use the launch TCB to figure that out. Makes sense, right? Cool. So the authenticity of the attestation report is a little bit interesting. It is signed with a key we call the VCK, or the version chip endorsement key, which is a key that is created by taking a chip unique secret that is blown in fuses and then mixing it with these security version numbers of the various TCB components. And this is done in a cryptographic way so that the firmware can never anticipate what the next VCK is going to be, like for the next version, but it is able to compute it for older ones. And so this is what allows us to, say, be running version 5, but produce an attestation report as if you were version 4. This is useful because in order to verify the signature of this report, you need a certificate chain that is shown there on the right, and this goes all the way back to an AMD root certificate. We provide this through a key distribution service, or KDS, and this is specific for each TCB version, and for each CPU. So when you do a TCB upgrade, you will need a new certificate in order to validate the attestation reports. And because these are now 2 different operations, right? You need to upgrade the firmware and you need to get a new certificate for it. We allow those to be split up. And as an example of this, so imagine that you've got your system, it's running version 2, you've been running that for a while. You can install version 3 of some component to try it out. You don't commit it, so we still have a committed and a reported level of version 2. and the guest will continue to see their attestation report signed with the version 2 key. At some point, you decide you're going to commit that version, but maybe you don't have the VCK certificate yet for it, so we're now going to still report version 2, so the old certificate will still work. And then once you get that new certificate, then you can bump up the reported version of version 3. So this is all about providing flexibility in especially cloud-type environments. Okay, so now let's pivot a bit to the Linux support for hot loading. And this is where I'm getting into the work that my colleague Ashish has done, along with support from some others in the community. So in the firmware for S&P, there are a couple commands that can be used to update the firmware. So the first one is kind of what we consider our legacy command, or the download firmware, which enables loading new firmware, but only when no guests are running. So if you shut down all the guests on the system, you can load whatever you want, as long as it is not a downgrade. There is another command called download firmware EX, which supports hot loading. So this requires that the S&P state of the platform is init, meaning that there may be S&P guests that are running, but there are no legacy guests that are running. This one supports both the upgrade and the downgrade, but there is a restriction on it. So firmware versions will have an attribute called min upgrade from, which basically says what the oldest version is that you can upgrade to, and that's, or I'm sorry, that you can upgrade from. That is really to kind of prevent an explosion of combinations of different firmware upgrade paths. And so the patches that have been worked on utilize the firmware upload API with sysfs to be able to load this. And so an example of this is shown here. So you basically write, one to this loading file. You provide the data. The data itself is something that we post on our website with the firmware images. And then you can write a 0 and then watch as the update is done. So there's a couple interesting things about this. So the first thing is about committing. So we talked about how you can roll back firmware until you go and commit it. And so the sysfs interface that's being proposed will not automatically commit new firmware versions. You have to do that explicitly once you're satisfied with it. Interestingly, the S&P commit function support is already in upstream, even though it isn't really useful until you get this support. And there is also a nice little utility called S&P host that can be used in order to invoke this. So you can do S&P host commit, and that'll commit whatever the current version is. The only thing that's really missing here is actually updating the firmware. And so after the patches, hopefully, get accepted upstream to do this firmware update, then we'll be working with the team here to add this capability to S&P host, and so you can do all of the management through that nice little utility. That can also set the reported TCB and such. That exists today. So there are a couple kind of interesting design considerations with this that I'll just go over. The first one I think we've kind of already solved, and the second one not really. So the first one has to do with those legacy guests. So I told you that we can't update the firmware unless the legacy guests are shut down. The interesting thing is that the way that KVM currently works is when you boot the system, it will actually initialize the system for both legacy guests and S&P guests because it doesn't know what you're going to run. And so in order to address this, the current plan is that obviously we'll detect if there's any legacy guests running, and then if there are not, it will actually issue, we call an SEV shutdown command to tell the ASP that we're not going to be running any legacy guests now, block the launch of those, do the update, make sure everything goes fine, and then reinitialize the platform for legacy guests afterwards in case you did want to start one up later. So I think that's relatively straightforward, but that is how we're addressing that. I think that's was easier than trying to change the existing flow of initializing the platform entirely, or automatically, I should say, on boot. The other case, which is a little bit trickier, has to do with a race condition around TCBs. So when a guest asks for an attestation report, it can ask for what's called an extended attestation report, which is where it says to the hypervisor, I want to get an attestation report and a VCK certificate associated with it. Now, the hypervisor has to go to the ASP in order to get the attestation report, and then the hypervisor would have the VCK certificate itself that it then provides to the guest. And so there's an issue here where if a guest asks for this and maybe some other thread is doing a firmware commit, then we have to make sure that whatever certificate we give back to the guest is actually the one associated with that attestation report. We don't want a case where the host is providing the new VCK certificate, but we still had an attestation report signed with the old one. So there's been two solutions that have been proposed. The first one is that KVM might read the TCB version before and after this attestation report is generated, and if it changes, then it will report an error to the guest and basically tell the guest that it has to retry in order to get a new report. The other solution proposed was that KVM could track how many pending guest attestation reports are in progress and refuse to commit new firmware until that drops to 0. I'm personally more of a fan of the first one because I don't really like guests telling the host that you can't do something for a potentially unbounded period of time, but this is an area that we're looking for feedback on. Or if there's maybe some other solution, that would be great too. All right, so that covers the basics of the firmware loading, but as I mentioned earlier, sometimes confidential compute makes things a little bit trickier, and this is just a preview of kind of what's going to come next. So sometimes we have bugs that simply require updating the firmware and moving on. The first one here is an example of a bug related to secure TSC. There was a talk about secure TSC earlier. And this was purely a bug in the firmware. So you updated the firmware, that was hot loadable, and the bug is fixed. However, we have also had bugs in the 4 years since S&P has been released that require more than just updating the firmware. So this one that's shown in the bottom was an example of one that required updating the firmware and updating the microcode and then shutting down all of the S&P guests and rebuilding the RMP. Right? So that is rather impactful, and that's something that we try to avoid, but sometimes it's inevitable. And the question is, how do we handle these kind of cases without causing a major disruption? And so there is a new feature that we have recently added to the architecture to help with this. And this is called a mitigation vector. So this is in the public ABI spec that we have posted. It is not yet in the patches. This will be coming at a future date. And this mitigation vector is a 64-bit value where each bit corresponds to a particular CVE that has these extra requirements. So not every CVE is going to get one. It's only going to be in these exceptional circumstances. And the idea is that instead of a verifier using strictly the version numbers in those 4 TCB structures described earlier to determine if a bug is mitigated, it would instead look at this mitigation vector. And so an example of how this might work is, let's say that there is a bug that potentially involves corruption of the RMP. And for those who aren't familiar, the RMP is kind of our big data structure that tracks page ownership. So if that gets corrupted, then the integrity of the system, as far as confidential compute goes, is compromised. So if such a bug exists, what AMD might do is we would issue a firmware update to fix whatever the bug is, and say that you also have to reinitialize the RMP in order to ensure that it's now correct. And after both of those steps are done, the mitigation vector bit for that bug would be set to 1. And any guests that start up after that point would see that that bit is set to 1. We'd report the launch time mitigation vector and a current mitigation vector and attestation and all this. But the important thing, the reason that we're doing this, is that it allows the host to still hot load the firmware even if just hot loading it will not fix the bug. So the host can hot load the firmware, they can test it out, make sure there's no problems with it, and then at some point they can shut down the guests, rebuild the RMP. So this is intended to make things a bit more flexible. There's also a new command that has been added to the spec that will again be supported in a future patch called S&P Verify Mitigation, where if we have a bug, and of course this is where it's hard because we're trying to anticipate what bugs we may have in the future, but if we have a bug that requires some additional actions, maybe not including shutting down guests, but maybe the host has to do something, maybe quiesce some things, and then we can make sure the system is still secure. We have an architectural way to do that now, and then the mitigation vector bit can be set once we successfully pass the verification. So this is all intended to, again, improve uptime, improve flexibility, and just make it easier to manage these firmware updates when we do have to have them. So that's basically what we have on this. The hot loading we see as an important feature, especially in cloud type environments. That said, as exciting as fixing bugs is, this has not exactly been going at breakneck speed. The last patch set for this was sent in November of last year. We are working on a version 7. There have been some ownership changes along the way, but I certainly welcome any feedback, of course on the mailing list or in person here, especially on some of the architectural challenges there. I think that the basics, it's not a very long patch set. I think the basics are pretty simple, but it is something that we think is important to making these features usable in more environments, especially in high availability ones. And as a conclusion, maybe you'll get a medal like this guy. So, any questions? Sean.
When the VSAC doesn't match the attestation report, what happens? Is that a host not doing the right thing so it doesn't burn the guest?
You're saying if the host were to provide the wrong certificate, it would fail attestation verification.
Then the guest would get mad.
Yeah. The host wouldn't know, and the guest might not know. The guest owner would get mad, potentially, right? Whoever is, like, the guest might fail to boot, maybe because it's not able to release a secret, something like that.
And then why can't we solve that in user space?
In which user space?
Host user space, you want to update your firmware and commit it. Why can't you just tell host user space, don't start new requests and make sure all your in-flight ones are fully committed? Or is there a problem because you can't know when it actually got back into the guest?
Yeah, I mean, the host user space would be the one initiating the commit, but it's the guest who's initiating the request to get the extended attestation report. So, I mean, unless you were to sort of quiesce all the guests and finish any commands that they were doing before you process the commit, which maybe could be an option. Sure.
With the whole SEN chain of things, what happens if very theoretically you push a firmware update that introduces a new security bug, you never commit it, you roll it back because it was buggy, but technically that guest was exposed to a bug that never shows up in any paper trail as far as I can tell.
Yeah, so, in that event, really the only recourse that exists right now is that we would have to issue an even newer version. So, right, you could imagine a scenario, version 5 is fine. We introduce version 6, which inadvertently introduced some security bug. We would have to introduce a version 7 that we could say, if you're, if your launch TCP was version 7, you were never exposed to version 6. Right. So that's the only solution that happens today. I will say I don't think we've had a case of that. Usually when there's been an issue with a new version, it's not generally a security issue. It's like it doesn't boot or something like that. We are, I would say, looking at ways to expand the amount of information that we provide with this sort of thing, but this is what we have currently. Yeah.
Yeah, it sounds like a PCR-like concept in the ASP plus a TCP log-like concept in the host user space would let you have a full chain of
Yep, that's something we're thinking about.
What prompts the guest to refresh attestation?
So, I mean, architecturally, we don't specify anything about this. And we don't necessarily expect guests to refresh attestation, which is one of the reasons that the earlier statement was that higher versions are better, on the idea that if you got a certain attestation report and you were fine with the versions you had there, then you should be good to go from that point. That said, you could imagine architectures where maybe guests do periodically refresh things to look at things, but I mean, really, from our standpoint, once you've passed it once, that's all we can really do. All right.
What's blocking you on the P7, if anything?
I think it's just cycles on our side. Yeah. So, as I said, it's a thing that everyone wants to work on. So. Great. Well, thank you all. I know it's been a long 2 days, and I think there's a closing session here in a couple minutes, right? I think so. Thank you.